There are 6 steps to balancing equations. So we're going to look at these steps first, then we're going to look at the bell work, lists 5 signs of a chemical change. So who can read there at the top of the page where it says steps for balancing equations? Points? All right, go ahead.
Most chemical equations can be balanced by following the steps given in table 9.2. For example, you can use these steps to write the chemical equation for the reaction between hydrogen H2 and chlorine CO2. That produces hydrogen chloride.
Okay, so the steps here, we're going to abbreviate them just a little bit. Step 1, write the skeleton equation for the reaction. So we're going to write the skeleton equation. The skeleton equation is like the recipe. If you go to a restaurant and you are making, let's say, spaghetti, right? The skeleton recipe would be just the basic ingredients, the spaghetti, sauce, right? The amounts, that's balancing. How much of each ingredient, that's the amount, okay? So skeleton is just the basic ingredients. Number 2, they want you to count the atoms. So you can see how they counted the atoms. And number 3, it says count the atoms of the elements and the products. So they count the reactants and the products here. And then number 4, it says change the coefficients to make the number of each element equal. So they're using these coefficients now, like we showed you yesterday, to balance. And then you're going to write the coefficients in their lowest possible ratio. That means you can't have a 7.5. It has to be whole numbers. And then lastly, you want to check your work. So as long as it's whole numbers, just like if you go to a restaurant, you can't deal with like, I guess you could, but typically products are ordered in bottles. You can't order half a bottle. That's what we're kind of talking about. So when you're placing these orders, you have to be able to, know how much of the oregano, how many pizzas you can make with it. Now, your major franchises already know this. They can give you an estimate of how much money you can make off each bottle of oregano. And that's when you start looking at your profit and trying to get close to that. So your manager will come in and say, okay, last month we did a really good job of maximizing our food preparation, and we were really close to increased profits. Now, hopefully they would share some of that profit with you, but oftentimes they don't. But if you want to improve your, I guess you'd say, worker attitude, you will. Ford does that. Ford profit shares a little bit. We hope more companies will choose.
No, I didn't.
Adam!
I'm sorry.
She's scared so much that she has like 3 foot goldfish.
Process. What?
Stop!
I'm in the
Dang!
process.
Dang!
I'm in the process of moving. I don't have time.
What do you guys do?
Where are you moving?
I'm in the process of moving.
Just making you like Randy.
Where are you moving? Where's that? Oh my god.
Yeah, we already know that.
No, that's right next to my house.
Okay, nice job.
Like at the beginning of the year.
Well, that's nuclear radiation. So, as far as how it's structured, the book balances equations, right? And then it goes into the actual type of equations. So we got synthesis, so we're going from balance to synthesis. We're heading to this next. But up here on the board, Hannah did a nice job of showing us the 5 types of chemical change. Okay, so chemical reactions are obviously the backbone of chemistry. We're talking about chinops. You're made of these. You're going to see it again if you go and you study like life, biology. So the law of conservation of mass says what?
Mass cannot be destroyed or created.
Right, it's accountable. So you should be able to find it in the mass, in the reactants and the products. Now, oftentimes, some of the mass can disappear where?
With the reaction.
In a form of a gas. So gases can be difficult to collect. Keep that in mind when you're doing a reaction. Like if you want something and it's going up into the atmosphere, it's going to cost you a lot more money to try to collect that. That's CO2 or whatever gas you're trying to make. So once again, we have the pattern here, X and Y geometry. And 10 points. 10 points. Raise your hand if you can tell me. If you look at combustion, what's outside of the pattern of the X and the Y and the A and the B for the combustion? What element is always associated with combustion? Raise your hand. 10 points. Look at the diagram. Pattern. What's present there? Combustion.
Oh,
You breathe it.
CO2.
Air.
You breathe oxygen. So you can see there the oxygen is associated with combustion, right? So you see the patterns here, X plus Y, XY, synthesis, decomposition A, B yields A plus B, single XY plus A, and so forth, right? Now on the back side,
Was that the one you put on the board? Is that one combustion?
Yeah.
It's behind the little thing.
yeah, we can go that in a minute. That's for the quiz. It's just another example of your cat being X and the fish being Y, and then you have the XY. So that's what we're going to kind of do tomorrow. You're going to come up with your own little cartoon. So I'll give you two examples, this today and then tomorrow. And we're going to reinforce these different types of equations, specifically the single replacement. The synthesis and decomposition are the easiest ones to get. I think combustion is too, because it's obviously oxygen. So here you don't have an element. This is not an element, but you have one product. So the key to the AB is that you have one product. Here you have an element, and once again you have one product. This would be a compound. Okay,
Am I right?
it's good to me.
Because then that makes this have another one, which makes it P4, which balances that.
2 times 2.
Oh, okay. So then that makes that balance that, and then you have to put 5 in front of this to make it 10. So like 5 times 2 is 10, and then 2 times 5 is 10, so it balances it.
Did you also
Nice job. Good job, Heather.
Single product AB. When two elements react, the reaction is always a synthesis reaction. Two compounds can also combine to form one compound. For example, the reaction between calcium oxide and water to form calcium hydroxide is a synthesis reaction. Another type of synthesis reaction involves a reaction between a compound and an element, as happens when sulfur dioxide gas reacts with oxygen gas to form sulfur trioxide.
All right, figure 9.7, they show you sodium metal, which is an element, plus chlorine, which is an element, forming sodium chloride, which is synthesis. Now, it's not always going to be element plus element. Like above in the reading, she says, you've got calcium oxide plus water yielding calcium hydroxide. The point is you always have one what? One what is synthesis? One type of, rest of the P, one product. So whenever you have a reaction and you make just one thing, it's going to be synthesis. They say synthesis or combination. Usually it's synthesis.
You got a phone in the room.
Yo, man, you know what happens to stitches?
Yeah, I'd like someone to try to give me stitches.
What? No, man.
You don't have the last person try to give me stitches?
No, man, you get compensated here.
That's got to be O2.
Oh, yeah, you're right, you're right. But that's 06, so I have to do 4 more.
What?
Well, it's going to be total 6.
What happened?
Well, you got, no, hold on, you got, your 4 is right, but you got
Oh.
6 here, so 2, 4, 6, yeah.
Yeah, yeah.
Makes sense? You got this. Yep.
So that's 6.
3.
Yeah.
3 times 2 is 6.
3. And then it's good on this side. No,
1.
right? I didn't miss it.
So this is a synthesis reaction. Okay. Synthesis. Now on the test, it's going to be like A 4, 3, 1, just so you're seeing how they're going to test you. Any question on that? What goes here? How many you see? All right, very good. So in your notes, there are 5 signs for a chemical change. We have bubbles, we have odor. So let's say you're running or playing a sport, you take off your shoes and you notice the odor. That would be a chemical change, bacteria. And you have a change in temperature. Let's say you consume, I don't know, potato chips. The potato chips, when they go into your body, are going to become the temperature of the body. The chips are going to increase in temperature. So, and they're going to react in your stomach. Change in temperature. Change in color. The food you take in is obviously different than the food you remove. It goes out of you. So that's changing color. Formation of bubbles, like if you drink a Coca-Cola and you belch, formation of bubbles there. Now, gas that's produced in your, I guess you'd say, stomach would be a sign of a chemical reaction. Now, I'm relating this to you because, Hannah, this is the best way to remember things. If you can relate it to yourself, you will remember it. If you're just like randomly saying things, by tomorrow you'll have forgotten it. Formation of a solid. That's a little more difficult to get a real-world analogy. But just remember that if you mix 2 things that are liquid and they form a solid, it's called a, raise your hand, 10 points. Starts with a P. It's called a precipitate. Michaela's correct. Good job, Michaela. So balancing equations goes back to Antoine Lavoisier, and he's the father of chemistry, and he basically came up with the law of conservation of mass. And this is such an important part of balancing equations. As you notice on this handout right here, Lily, where it says balancing equations, both sides of the equation must have the same what?
Did you say Antioch?
Antoine?
That's not how you say it.
How do you say it?
Antoine.
Antoine?
That's how my dad's name.
Oh, is it? Antoine? Okay, that's French. Antoine. So Antoine there. I apologize. Antoine. I'm not French. I don't speak French very well. I apologize.
So your dad's name is French?
Antoine.
What's Michaela?
So what? The question is, Michaela, right here, on the balancing equation, both sides of the equation must have the same blank for each element. Same, starts with the M.
Matter. No.
Same, yeah, it's close. Mass, same mass. Very good. So the law of conservation of mass is what we're gonna. It's kind of our guideline for balancing these equations. Right now, Science Olympiad's coming up, so is Science Fair, and every year we try to have somebody get up and pronounce names for students. If you'd like to do that, you can raise your hand. We need a volunteer
What?
to pronounce students' names that win.
No.
Really? You want to volunteer?
You have to go?
Yeah.
Okay.
You want to do it? Maybe. Very good. So the steps here are listed. First one, it says write the skeleton. If you're at a restaurant and let's say you're making spaghetti, the recipe is just the basic ingredients. That's the skeleton equation. When you balance it, you're saying how much did you use? Did you use 2 cups? Right? Does it make sense? 2 cups spaghetti. All right, so step 1, skeleton. Step 2, count the atoms, specifically the reactants here. Count the products. In step 4, you're going to use the coefficients to balance them. In step 5, you cannot use fractions. It has to be whole numbers. Then you're going to check your work. Now the next thing we want to look at are the types of equations. Step 1 was to balance them. Now we're going to look at individual types. Who wants to read where it says synthesis, page 289. All right, TT.
Figure 9.7.
Conservation of mass. Law of conservation of mass, page 288. Now over here you'll notice that on the figure 9.7 you'll have an element plus an element making a compound, right? Now the thing with synthesis, you always have how many products? Raise your hand. Points. 5 points. How many products do you have when you see a synthesis reaction? Yes, 1. You have just 1. 1 product. You see NaCl is 1 product here. AB, does everybody see AB is just 1 product? Any question on that? Synthesis, 1 product. Where you have hydrogen plus oxygen forming water, that is a combustion reaction. Now the question is, this is both a combustion reaction and a synthesis reaction. Why is that? Why is it a synthesis reaction? Making 1 product. So anytime you see 1 product, synthesis reaction, oxygen combustion. Now if you look at the one beneath it where you have methane plus oxygen, how many products do you see? Yeah, you see CO2 and water, and that's the reason why this is not a synthesis reaction. It says, for example, the reaction involving methane gas and oxygen illustrates a combustion reaction in which one of those substances will replace another in the formation of products. Right up here it says, however, not all combustion reactions are synthesis reactions. So this is an example of a combustion reaction that is not a synthesis reaction. It's perfect.
Okay, that's right.
Yep.
Okay, and then
You're helping other people learn.
I don't like it. Wouldn't you just add 3 on?
Exactly.
1, 2, 3. Right?
Yep.
And then draw a line.
Okay, or you can just put the numbers at the top because there's a blank there.
4.
Yep.
And then 3. And then 1.
Right. So on the test on Friday, or quiz that is, it'll say like A will say 4, 3, 1, and B will say, let's say 3, 4, 1. So you're going to say A is correct. You see how that's how it's going to work?
Yeah.
Just be aware.
So there's one of these. That one only has 1. Yeah.
That's a problem. You have one of these and you have 2 of those.
No, that means
That's good. So it's on the test it would be
2, 1, 2.
Simple.
yeah. It's synthesis. Well, if you do 2, you have 8 of these now, and you have 2 of these. And you have 6 of these, and you have 5 of those. That's a problem.
I give, I am, I know,
You're saying 8 phosphorus, but you have 2 phosphorus here. Conservation of mass, both sides have to be equal. Okay, if you got 2 there, that's good because you got your phosphates balanced. Your phosphorus, not phosphate, your phosphorus. Right, so you have 2 and 2 is 4, so you got 4 there. What's 5 plus 5?
10.
Now what's 10 times 2?
20.
So what needs to be there?
20.
No,
5.
5. Because 5 times 2 is...
What?
5 times 2 is what?
10.
So 5 plus 5 is what?
10.
So you can see how it's balanced now?
Yes.
Copper sulfate, which is blue, and you heat it, it will turn white. Now, you would think that would be a chemical change, but it's not. You need to see 2 signs for it to be a true chemical change. You need to keep that in mind. You need to see like a color change and a temperature change. Color change and an odor. You need 2 signs for it to be a chemical change. 1 is not good enough.
It can help you remember and understand them. It can also help you reorganize patterns and predict the products of many chemical reactions. One way chemists classify reactions is to distinguish among the 4 types: synthesis, combustion, decomposition, and replacement reactions. Some reactions fit into more than one of these types.
Alright, so yesterday we introduced balancing equations, and today they're moving on and kind of identifying the equation types. So synthesis.
You can give her another one. She can do it now. She understands.
Okay, so what's the numbers going to be?
How many of each?
Right up beside it, right up beside it.
So, like, how many of this?
How many of this? How many of that?
Well, that's
No, how many of these?
How many of that section? In each circle. 2.
Yeah.
So basically you want to have a number, not like that. There'll be a blank right here. There'll be a blank right here.
Oh, okay.
So you got to put the numbers there.
1, 2, 3, 4, 5.
Noah, which of these justify a chemical reaction? You don't know? All right, Alex. None of the above? No. 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 Well, you need more than 1. You're close, Alex. You have to have 2. If you just see a color change, right? Only a color change is not good enough, because you can take copper sulfate, which is blue, and you heat it and it turns white, but all you did was remove water. So a color change is not enough. You need to see color, temperature, color, odor. The sheet here lists 5 signs of a chemical reaction. These are the 5. I'll zoom in for that.
But I always think it's production of an odor.
You actually need 2 of them. That's good. You said both of them. You said solid and odor. You always got to find 2 of them. Because if it's just 1, it could be a physical change. Like if you had copper sulfate, which is blue, and you heat it and it turns white, that's just a physical change. So always look for 2. If you got 3, even better. 2's good.